Hey everybody, thanks for joining us on Code Chat. My name is Jeremy, and I'm joined today by Matt, and we're going to be talking about Rx.
Yep.
Matt, let's say you and I are at the airport.
Okay.
We're going different directions on moving sidewalks, and I ask you, what is Rx?
Well, the easy explanation here is what we have on our website is an API for asynchronous programming with observable streams, but that's not all that interesting, is it? More along the lines of think different. I would say the easiest way is to think differently about async and events, to think about them as you would a collection of objects, sort of like an array or something like that. Now you can think about that you can take mouse clicks, you can take an AJAX call and turn it into an object with 0 to infinite values that you can just pass around to people. Because traditionally with events, you know, you have add event listener, remove event listener, and you have a handler. Well, here I can hand you all the mouse clicks or all the mouse drags and that sort of thing that you can really start to build some really complicated user experiences from.
Now, Rx seems to me to be one of those technologies that has kind of a steep on-ramp. I remember the first 4 times I saw it, I said, that's kind of interesting, but I don't have time to get into that right now.
Yeah, there was certainly that. I think we were well ahead of our time, you know, because when Rx really came out, it came out of a project called Volta, which was the idea that we could write a single application and tier split it to say this part runs on the server, this part runs on the client, and then, oh, by the way, we can recompile the client from C# into JavaScript. That didn't go off, you know, according to plan. But what did kind of fall out of that was thinking differently about async.
Okay.
Because we had this trying to think about async in C#, which lacked task of T at the time and only had the begin and end async pattern.
Those were terrible, honestly.
And async result days. Or you had events, but there was really no way to marshal those across a boundary, especially if I was going to take it in C# and put it over into jQuery and JavaScript. So that kind of thing led us to this discovery of thinking differently about asynchronous programming. So we came out with RxJs back in 2010. We showed it at JSConf 2010. But it really wasn't until we open sourced it in 2012 when people started to really look at it. It also helped that one of the early adopters of Rx was Jafar Hussain, who then went to work at Netflix and was evangelizing everything that we did. Because if you remember the Silverlight toolkit from back in the day, all of the particular controls that were in there had tests written in Rx. So that was kind of the first test bed, as it were, a real big consumer. And then what people found over time is that, wow, this is really useful for building pretty much our entire user interface when it comes to data binding, data access, animations, etc. But it was kind of a more of a closely guarded secret in terms of how they did it until Jafar and myself started doing a lot of talks in the 2012, 2013 time frame. And in so much so that I've gone to a lot of conferences and kind of showed, yes, I can show you the 101 kind of examples, but here are some really, really hard problems that they were trying to solve, such as, dealing with a low-end device and making sure that only what's on the screen is kept in memory, and everything else in terms of all the other movies are not in memory anymore. So when you scroll through, it gives you a very good experience in terms of keeping the memory footprint low, making sure all of the handlers are removed, et cetera, or just the basic autocomplete of being able to take these key events, such as to be able to do this, and now I can start typing here. And sure enough, as I start adding things, And what it does is it basically waits a little bit before, because of a super fast typer, the last thing you want to do is you want to send over 10,000, 20,000 different requests. Instead, you want to wait for the person to finish their thought. So to do that, we added a little debouncer kind of function. And so I showed at a recent conference the sheer amount of code to write this is actually fairly small. It's basically taking the key up events and it's mapping to get it's going to get the value from the text box here, and then what it's going to do is do a little debounce to make sure that we're going to only listen for every 700 every second basically when I've stopped typing, and then it's going to go over, make an AJAX call, and return the data. So to do the same thing in jQuery literally took me about 2 pages worth of code versus this, which is only about, say 6 statements.
Okay, so let's take this one example that you're sharing right now. This is something, a user flow or a user experience that's been around for a long time. It's a fundamental part of what a lot of us do on the web. Mm-hmm. And there's by no means any reason why we can't do this using other more imperative approaches, using jQuery and every time I type a key doing this. But what we're talking about with Rx is a paradigm shift.
Absolutely.
That results in a scenario like this being a lot less code. And in my opinion, when I look at a new framework or something, when I see that something is a lot less code, I get excited because it means this is a more essential concept. This is closer to the way that it should actually work. And I have this hope of being able to use this language or this library to do the essence of what I want to do without a whole bunch of imperative ceremony. Yeah,
I mean, to further explain kind of what this is you can think of as this text box here as a stream of values containing this particular text here. And then what I'm going to do is I'm going to add those little debouncers and make sure that in fact, like for example, when I go left and right, the text itself isn't changing, although there's an event firing behind the scenes of the key up, but it's not actually firing that event again.
I see.
So it's not once again incurring any hit on what we're trying to do. But if you go down further here, all of these then turn into it's a stream of value as well. So it's basically transforming this into this.
Okay, much like I would do with an array map, right?
Correct.
An array filter, an array map. So we're talking about these operators that can affect these streams.
Correct.
In a very generic way that applies to a lot of different scenarios, right?
Absolutely.
Okay. Now, one of the things I've been watching a lot of videos on Rx lately.
Okay.
And one of the ways that it was described was really helpful to me, and that was somebody said, don't think of it so much as sync async as push versus pull, and no longer having to go and ask a question every so often, but rather giving the observable the ability to be basically to be in control, right?
Yeah, absolutely.
It's the one that tells me when something has happened.
It's the old Hollywood principle, don't call me, I'll call you kind of thing. is you basically hand your business card and you hope and pray that it'll call you.
Yeah.
That absolutely is the case, because in traditional slides we've talked about the 4 quadrants of the async and sync things, where we're in the lower left-hand corner where you have sync and single value, you just have a value, and for multiple values that are synchronous, we have an array, set, map, whatever we have.
Sure.
In JavaScript. And then when we flipped over to the async world, then we had the promise there for dealing with single value async. And then what we would throw up into the asynchronous and multiple value is the observable. But is that really true? No. It's in at least the way that Rx is written right now, through versions 4 and 5, is no. It's potentially async, but it doesn't have to be.
Okay.
And so much so that when I'm just dealing with simple data binding, nothing about that is particularly async. Is that I create a value and I bind that value. It's perfectly synchronous. But it is exactly as you said. It's that push versus pull mentality, where when I call array for each, that's a pull value. I'm telling every single time, give me the next value, give me the next value, give me the next value. When I call subscribe, that on the other hand says, okay, I've got a handler for me, or I've got this bucket. Start shoving values in here when you're ready.
Yeah, right. Well, that's good though, because it means that it has the ability to do both. Sync
Correct.
and async, right?
Correct. Yep.
Okay.
Yeah, but and that's why people have started to adopt this, in conjunction with things like Lodash and so forth. But they use observables for really the more intricate parts of of transforming an object in these pipelines, as it were.
Now this isn't just a convenience. There are some things that Rx adds that I otherwise wouldn't get. For instance, I'm familiar with using arrays of promises to go and do a whole bunch of web requests.
Right.
And Rx is fundamentally capable of not only doing that in a shorter and more elegant and more expressive way, but it's also able to cancel those web requests when they're no longer serving any value.
So that's a really good point. And in fact, what I can show you real quickly is kind of how that works. So, for example, when I create an observable, I can go ahead and, let's see, can I make it a little bit bigger here for people? There we go. Better?
Yep, that looks pretty good.
Okay. So what I can do is I can create a new observable. So let's say let O is equal to observable.
And we're just in the node REPL right now, right?
Yeah,
just
correct.
Right, node cowboy style.
Exactly. So if I do this, okay, so I'm going to say O dot on next, and I'm using RX4 here, so I'm not using RX5, but that's okay. And I can say on next 56, and then I say O dot on completed, and then I can return a function that basically says whenever I'm done, do something. Whenever I'm done, or whenever there's a cancellation, do something. So in this case,
clean up.
Yeah. So in this case, I can just say, let's be a little bit more modern.
Yes.
Let's be a little bit more.
We have to shed these old habits.
Exactly. So we can do that, and then.
Well, you're not a semicolon guy, Matt.
Not on the REPL. I don't have to worry about ASI here.
Not when you're in cowboy mode.
Exactly. So I can say O.subscribe, and then what I can do is I can say.
Okay, now pause for just a second here. No, that's fine.
Okay.
You can keep that typed. But for people, what you've done is you have created an observable object using this factory function, and now you're going to subscribe to that. So you're talking both sides of the fence here. You're talking the guy who's going to be generating events and determining when they happen. Here you're determining that they're happening, and now you're going to consume that, right?
Yeah, and you can think of it almost as a dependency injection, as it were. So O.onNext. So basically, when I'm handing you the observable, I'm handing you the kind of the receiver. Telling the receiver what I want to shove into it when I'm doing this, and here I'm going to shove two values in there, and then I'm going to say I'm done.
And these are happening now. There's no asynchrony here, right?
No, there's no asynchrony at all. And then afterwards, when I call dispose or unsubscribe in RX5, then this particular thing happens.
Can you tell me when this particular thing happens? When does that function actually run?
Okay. Well, see, as you can see, nothing has actually happened, and they won't happen until I call subscribe.
Okay.
So this is lazy. Perfect. Yeah, it's perfectly lazy. So if I can say console.log v, and then what happens is I see 42 and 56. Okay. And then also, because of the fact that I hit on completed, it automatically disposes for me.
Okay.
But if we take that previous example at O is equal to observable.create O, and then I just do O.onNext 42, and then return console.log disposed, and then do that.
Okay.
Oops. Oh, shoot.
Oh, boy.
That's what happens when I decide to use let instead of var, but that's okay. So O.onNext.
Build this again.
Exactly. And then There we are.
That was impressive, by the way.
Thank you. So if I go 01 subscribe, actually, let's get a var s for our subscription.
The console skills are strong with this one.
Exactly. Subscribe v console.log v. Okay, so I see 42. Now the subscription happens to not be disposed, but now...
So this is like an unresolved promise, maybe?
No, it's more along the lines of, as I start to create these bigger and bigger streams, like for example here, it contains all of the logic inside of here on how to clean up afterwards. Okay. So for example, if I'm combining multiple events together, and then when I call unsubscribe or dispose, then all of those handlers get removed, via remove event listener. It's that kind of thing that happens. So if I say s.dispose, suddenly disposed is called, and now we're good to go. So basically anything that you need to have happen in terms of whether it's finishing naturally or unnaturally, you will always have a deterministic way of cleaning up.
Okay.
When comparing and contrasting with promises as defined in the ES6, ES 2015 spec, there is no notion of this finally, as it were.
Okay.
There is no notion of the chain is complete, and I wanted to do some deterministic cleanup. There isn't any of that as well.
Okay.
Just as there isn't any notion of cancellation either. Okay. So it's missing both of those things that observables already give you.
Okay, now you showed us this type ahead example. Mm-hmm. I want people to see the value of considering everything in the same way, considering everything as a stream, and then being able to use all of these operators on there, like the ability to merge streams together and filter them out, just as if you were dealing with an array, even though this array is things that may be delivered 5 seconds down the road or 3 minutes down the road or whatever. So can you show us the example of the canvas, where you draw on the canvas using the observable? Okay.
So what we have here is we have a very simple example where we can just paint on the canvas. Everyone's kind of seen this, where you can start to draw things that look kind of like circles.
By putting the mouse down and dragging it? Okay.
Yes, by going down and then mouse move and then take until mouse up. So it's that kind of combination where you're doing mouse move and mouse down and mouse move until mouse up. But it gets a little bit more interesting as we start to think about this color palette or this color picker down below, because each value in here is an observable as well. So for example, by the very nature of me clicking red, and now I can start drawing. How in the heck did that just happen? How it happened was the fact that I could take this particular stream here, which was the normal drawing, and then I can combine the latest from what people have chosen from the color palette, and I merge them together. So I give you not only the position of where the dragging happens to be, but also the color from this particular piece down here. So you kind of merge the two together, and that's where the magic kind of happens. So
as a developer, I kind of have to start changing the way I think about problems like this. I'm used to thinking about the different events on the page, and then saying, let me go create myself a handler, and when that happens, what do I want to happen? And then it gets difficult when A, I have to start cleaning up after myself, and B, when I have to start combining those.
Correct.
I mean, we've all run into this problem where the key comes up, and then you have to start asking a whole bunch of questions. Was the control key also held down? Has this happened? Am I here? What's going on?
Yeah. Whereas I can already filter those out using .filter, and I was like, well, what key was it? Okay, it's not that key, so throw it away. Or I can say, look at the past few keystrokes. Well, you could actually go back and model, say, the Konami code, for example, actually as a stream, because what you can do is you can do that look ahead and look behind on the stream and say, were the past 10 characters up, down, left, right, B, A, and then if it is, and then suddenly it's going to go, hey, you've got the Konami code.
Would that be a window? operator?
It would indeed be a window operator.
All right, wonderful.
Yeah.
My studies have paid off.
Yeah, or either it'd be the window or the buffer. The buffer
Okay.
would just do a comparison of the array to the other array, or you can do window 10, skip 10, and then do a sequence equal.
Okay.
To do these two sequences equal each other, and then sure enough, you've got the Konami code. So yeah, you've got any number of things of thinking about these streams as everything on the page is potentially a stream.
Okay. Now, Matt, tell us where Rx is used in the wild today.
Okay. Well, everything. So people that are using Netflix, for example, everything on their Edge websites and so forth is using Rx, even down to the smart TVs that you happen to have. It's a rather old version, but it's still Rx nonetheless. And where they use it is a number of things. They use it for animations, data binding, data access, any number of things. And what was really helpful for them, especially, was the fact that they also decided to implement RxJava at the same time as they started to adopt this, because they saw it was really, really valuable to do that. And they were already using Rx.net as well. So they were all speaking the same language, as it were, the same framework language or library language. They could be speaking Java and JavaScript, C# and so forth. But they would also be speaking the same language, the same language of streams.
Yeah.
So any of those particular sites are using that, and what's great about that is the Netflix community has been pretty active in terms of contributing to Rx, and in fact, moving from RX4 to RX5, where we're kind of redoing and making it a lot more modular, a lot faster, and so forth. In conjunction with Angular 2, which leads me to my next one. So Angular 2 is going to be a place where the HTTP module that people had used before was very much promise-based. Well, now it's going to be observable-based.
That's phenomenal.
In so much so that people can start using these various combinators, such as, or operators, such as the ability to retry something 3 or 4 times, to do a catch and return some default data, to do any number of additive things that they want to massage out of that particular stream.
The retries in one line is really impressive.
Yeah.
Being able to do retries to HTTP calls is pretty great.
Exactly. And I can show you briefly what that means. So let's do var o2 is equal to observable.create. Actually, let's first do a counter. So var count is equal to 0. And then I can say var o2 is equal to observable.create o. And then I can say if count plus plus is less than say 2, o.on error. And
so you're kind of throwing right now, right?
Yeah.
Okay.
Yeah. So there is no real such thing as asynchronous throwing.
Right.
So we're doing the best that we can on next 42, and then we'll just leave it as an empty cleanup because there's really not much to do there. But yeah, here we can say o2 dot.
Can we tear that apart real quick?
Sure.
So you just created an observable.
Yep.
And you said for the first it's starting at 0. So for
Yep.
0 and 1,
Yep.
it's going to throw an error.
Correct.
But then after the 0 and 1, so the
Yep.
third iteration, it's going to spit 42, right?
At a certain point, yes.
Okay.
But so there are a number of ways that we can get around this. Obviously, is we can say o2.catch, and I can say. Like, for example, if you're going to do something like deal with cached values. So if you're dealing with asynchronous calls to an XHR, if you've got some cached values, you can just kind of shove it in here as part of the stream and say, well, I couldn't make the call. I'm going to give you some default data.
I see.
And we can go from there. And now I can subscribe, and And as you see here, 56 happened instead of the 42 here.
Okay.
Now, if I go back, though, and I say retry, say 4 times.
What did that mean to catch, inject your own one value observable, and then subscribe to that?
Okay. So when I said catch here, basically I said if anything bad happens, which meant that on error happened, I can substitute it. There's a number of other things I can do. I can say, for example, I can put a handler and I can look at, actually inspect the error that came back and say whether to do this or that, some sort of conditional logic. But at the same point, you just might want to just shove some default data in there.
Okay.
So here we can say I'm going to retry, run it again, say retry 4 times, and see what happens.
And then catch if it doesn't.
And then catch, and if it's still bad. And now, obviously, it did 42 because it went through and it said, okay, 0, 1, 2, aha! It finally succeeded, and now you can keep going.
That makes good sense.
Yeah. So, I mean, if you really want to think about, Rx in terms of the real compositional thing, you obviously think of games. You think of people, any number of things such as games, such as, React. These things here are timers. Well, each letter is a stream into itself that you're happening to do. In the fact that also all of the frames per second, that's an observable. The bounds detection, observable. All of these sorts of things just happen to be observables. And even doing simple things like making Mario walk across a screen is also very much an observable. And the fact that he can go like this, he can change directions, all of those sorts of things are observables in terms of how he's not continuing to jump off the screen even though I keep hitting up. At a certain point, all of the bounds detection, all of those sorts of things. But going back to where it's actually used, so Angular is obviously a huge one there. We also have Microsoft products such as Delve and OneDrive is being used there. We also have places such as Slack for Windows is actively being used there in a number of really interesting ways, such as all of the spelling detection and spelling correction that it happens to do, because once again, all of your text is a stream, and as you're typing along, it can figure out the language that you're using, and then basically go, oh, what he really means is this, you dummy, and and fixes that for you.
Gotcha. Wonderful. Okay, well, we're pretty much out of time, Matthew, but thank you so much for showing us that. Real quickly, how does a person get involved? What's the easiest way? Then they learned a little bit today, but what's the easiest way for them to on-ramp onto Rx?
Well, there are a number of ways. We have the great Learn Rx site, so we have a lot of these resources just basically built off of the ReactiveX.io homepage that we have here on how to get started. You also can look at this particular reactive extensions for JavaScript repo. We have a lot of resources there. And not only that, but if you really want to understand and do all of that, get involved, because we have so many committers right now to RX5. It's heartening. At the same point, it's like mind-boggling that so many people are spending so much time to make this a really awesome and fast library. So those are really 2 good ways of getting started.
Wonderful. I've found a lot of videos in conjunction with Angular 2 just because of the excitement around that upcoming framework.
Right.
So you can find a lot of videos online that kind of teach you Rx and Angular 2 at the same time.
Exactly.
So there's that.
Yep.
Wonderful. All right. Well, thank you. Thank you for joining us. We're actually going to be having Mathew back again to talk about another framework that he's working on. So you'll see more of Mathew a bit later. Thanks for joining us on Code Chat, and we'll see you next time.
Thank you.